Today's session from DSIM Academy, the do's and don'ts of monitoring your data center infrastructure. My name is Matt Bichelle, Director of Product and Corporate Marketing at Nlyte Software. Sev Anishkevich is going to give the presentation today, and Sev is currently the CMO, Chief Marketing Officer at FieldView Solutions, a leading data center infrastructure management software vendor. At FieldView, Sev is responsible for strategy, branding, communications, business development, and international expansion. Previously, Sev had lent his expertise to Invino Veritas consultants, providing marketing strategy and market and partner development for technology businesses and new technology products. As Vice President of Global Marketing at Raritan Computer, Sev championed their international expansion, growth, and entry into the power management space. Sev holds a bachelor's degree in electrical engineering and computer science from Princeton University and an MBA from the Wharton School at University of Pennsylvania. So with that, it's my pleasure to introduce Sev. Sev, take it away.
Thank you very much, Matt, and thank you everybody who's on the line. Good morning, good afternoon. I also noticed there are quite a few people from Central and South America, so buenos dias and bom dia. First, would just like to briefly introduce FieldView Solutions, so in case you're unfamiliar with us, you understand what our perspective is and where we're coming from with this presentation. We're the largest independent software vendor of purely DSIM monitoring solutions, and we'll talk about specifically what that means shortly. The name of our software product is called FieldView Infrastructure Software. We're US-based. We've been around since 2006, and our 6.0 release is our 17th version that's out on the market. Our customers number some of the world's largest data centers across 6 continents, and they range from a low of about 1 megawatt to a high of over 100 megawatts for a data center, and a number of the customers have multiple data centers. So you can see that our customer base is somewhat skewed towards larger installations, and it is our discussions with these customers that really form the basis of this presentation. And so what I'll be doing today is really giving you some of the learnings of what's worked and what hasn't worked with our customers in terms of implementing DSIM monitoring. And before I do that, let's define terms and what is DSIM, and then specifically what is DSIM monitoring. So DSIM, Data Center Infrastructure Management, is a term that's been bandied about since about as long as FieldView's been in business, since the mid-first decade of the millennium. And it's meant many different things. I think if we had 600 people on the bridge here, we'd have 605 different definitions of DSIM until recently. And of late, the key analysts in this space, people like Gartner, people like 451 Group, IDC, Forrester, EMA, who look at this space, have developed a more crystallized definition or taxonomy of DSIM, not as a specific piece of software, but rather as a category of software, just like Office software is a category and consists of many different independent modules. Those modules interrelate like they do with Office. So the history of DSIM, if you roll back about a decade, was definitely the hype cycle that Gartner publishes. And there was a lot of hype. There were literally hundreds of vendors purporting to do DSIM. The visions of delusions of grandeur, utopian ideals that DSIM would be a panacea, the be-all, end-all, the cure-all for everything and anything inside a data center. You had a lot of implementations that tried to boil the ocean, tried to do absolutely everything simultaneously. You had a lot of vendors that pretended to be able to deliver a complete solution of everything related to a data center. And after hype naturally comes collapse and that trough of disillusionment. We hit that a year or two ago, and subsequently the market's really gone to that next stage of maturity, crossed the chasm as it were, and it's now climbing up that slope of enlightenment where companies are buying it not because of the hype, not because of the sizzle, but because of the actual benefits, the returns on investment, the increased operational efficiencies, the increased reliability that you expect to have now when you implement a DSIM solution. So what's really changed in the past 2 years as the industry's matured is both the vendors and the customers have a much more realistic expectation in terms of what they do themselves, the value that they deliver, and the value that they expect to receive. And instead of having these intergalactic implementations where you try to do absolutely everything at once, you're now doing a much more rational, piecemeal approach that demands and delivers benefit at each stage. And I'll talk to you a bit about those pieces, those building blocks of DSIM. But first, we wanted to have a question to all of you to understand what you're currently doing with DSIM, if at all.
Okay.
And Matt?
Yeah, so up on the screen, everyone should see the question that we're posing to you, which is, what is the primary usage in your organization for DSIM? And you can select all that applies: monitoring, asset management, other. So you could possibly check all three of those. Or if you don't currently use DSIM, that's okay too. Seb and I just want to get a feel for the audience. So I see a lot of respondents coming in now, so I'll give it another few seconds, Sev. And okay, I will go ahead and, well, people are still voting. This is great. Okay, so I'll go ahead and close the poll, and then Seb, in case you can't read it, I'll read it aloud. So 51% do monitoring, 33% asset management. We have 15% other, and 43% are currently do not use. So so there you have those results. 51, 33, 15, and 43%.
All right, so this would be one of those poll questions where the answers can add up to more than 100%. So clearly we see quite a few people that are doing both asset management and monitoring, which is good to know. And these are really the two basic building blocks of DSIM. There are a number of applications. Different analysts will have a different number of categories of the applications and the modules within DSIM, but there are dozens, if not close to 20, depending on which analyst. The two fundamental ones, in every analyst's opinion, are DSIM monitoring and DSIM IT asset management. And collectively, those two represent more than 80% of the total DSIM market. The other areas range from CFD, computational fluid dynamics, to dynamic adaptive cooling, to load shedding, power capping, various other sophisticated control mechanisms, some deep analytics, and what some call DCSO or DSO, data center service optimization, which is an analog in relation of DCIM to your IT service management applications. But the majority of the market today and the two foundations are actually monitoring and asset management. So it's actually refreshing to see that that's reflected in this online poll here. Most of these other applications don't stand alone. If they do, they require either real-time data that you would get from DSIM monitoring and or information about what's installed and what's coming down the pike in a data center, for which IT asset management is the repository. DSIM monitoring is really collecting real-time data, storing it, of course, historically, about the physical aspects and what's happening in the infrastructure, second by second, minute by minute. It generates huge amounts of data, but it's ephemeral. That data changes constantly. IT asset management, on the other hand, is somewhat more static data. Servers don't move around in racks multiple times a minute, but there's a lot of data about each server. So there's a depth of data versus a frequency of data collection. And collectively, IT asset management gives you that understanding of what you physically have, and DSIM monitoring is of what it's doing. The monitoring tends to have a stronger affinity to the facility side of the house, IT asset management obviously to the IT side of the house. The combination of the two, however, is much more powerful than either independently, because you get that end-to-end view and visibility so that the facilities folks understand what equipment they're powering and cooling, and the IT folks understand what capacity and what implications there are on future decisions about operational deployments. So that leads us to focus on the DSIM monitoring. And the first question will be, why monitor? And I'd give you two answers that are somewhat consistent. One's a pithy one by Lord Kelvin. Kelvin, of course, defined and was able to measure absolute 0 degrees Kelvin, and he's all about measurement and monitoring, and it's about measuring as a source of improvement. James Harrington took Kelvin's maxim and elaborated on it, and really made it a multi-step process where measurement is the first step that leads to control and eventually to improvement. Premise, if you can't measure it, you can't understand it. If you can't understand it, you can't control it. If you can't control it, you can't improve it. And I'd add, if you improve it and then don't measure the improvements, you'll never have that feedback loop that says, here's what I intended to do, here's how I did, here's what I should do, and here are any course corrections I need in the future. And that applies very much to DSIM monitoring. So what is DSIM monitoring more granularly? So it is a collection and aggregation of what you may already be doing in a data center. The larger you are, the more likely it is that you have multiple monitoring tools. They come bundled with your IT equipment, with your cooling equipment, with your power equipment. You have a building management system. You have an ITSM system that's measuring at the server, at the application layer. You have battery monitoring solutions. You have many different point solutions of monitoring, each with discrete subsets of users. Some facilities people, some IT people, your IT ops people, and your senior management. And they all have different things they monitor in different ways, but very often they don't see what the other people are seeing, and they're only seeing a part of the picture. DSIM monitoring is about aggregating all of the existing monitoring, filling in the missing holes, i.e. measuring additional data points that connect everything, and then logging that information, not only presenting it in real time, but logging it so you have historical trending data. And you can look at what your peaks are and your averages are, which is invaluable when looking at capacity planning and what's coming down the pike. Since you're monitoring, you're also looking at alerting, so alerting to not only something that's already gone off the rails, but probably more valuably something that is potentially going to go off the rails, giving you enough advance notice so that you can forestall that and remediate the situation before it becomes a problem. So that's the monitoring. And over time, the industry analysts, the vendors, the customers have been looking at how do I turn that monitoring into an ROI story? What's my return on investment for implementing a DSIM monitoring solution? For that, we refer you to a study that was conducted by EMA, Enterprise Management Associates, and their answer was that there's a very substantial ROI, but the specific way in which different customers define and value the return on investment differs dramatically. And that there were actually 6 separate categories, 4 of which are fairly easy to measure and 2 of which are more subjective, that stem from a successful DSIM implementation. And the first one is the thermal management. If you can safely raise the ambient temperature in a data center, essentially for every degree Celsius, you can save roughly 4% on the power costs. And if you can raise by 4 degrees, that's 15–16%. And the study found that the typical data center that was able to do that and use DSIM in order to raise the temperature was able to achieve about $150,000 annual savings in power. That's normalized down to a small 10,000 square foot data center. So obviously larger data centers would have larger and smaller data centers would have smaller. Second would be other aspects of saving power through consolidating not only servers, but also consolidating workloads, consolidating the loads on UPSs and other power infrastructure, where optimal loading and basically disposition or turning off of unnecessary equipment was able to achieve a $230,000 per year savings in power, again normalized down to that 10,000 square feet. The other 2 here are more labor savings, the savings of not having to have people manually take measurements to operate a data center. And the big one here, and I'll discuss that in further detail, is really the increased operational efficiency that you see when the IT and the facilities side can work harmoniously, and you need fewer cycles and much less time to make critical decisions such as where do I deploy these blade servers, and with fewer problems. The other 2 that I mentioned, there are 6 categories. The other 2 are delaying or deferring capital expenditures. A good DSIM monitoring and asset management solution can give you the capability of extending the lifespan of your existing infrastructure. So you find enough stranded and underutilized power, space, and cooling capacity that you can delay, defer, or even cancel planned data center build-outs and expansions. So the deferral of capital expenditures can sometimes be in the hundreds of millions of dollars of savings. And the 6th, and certainly not the only benefit, is also the increased availability, reliability, uptime, which for many companies translates into positive ROI, and a proper DSIM monitoring tool can help increase that availability inside a data center. So that's what it is. That's the why people do use it. So now let's talk about the how they use it and what's worked and what hasn't worked. So we have a number of do's and a number of don'ts. And we'll alternate a do and a don't. So the first of the do's is do integrate the 2 basic building blocks, the IT asset management and the DSIM monitoring, because that's really where you get the 1 + 1 = 3 from really getting the IT and the facility sides to work together to get visibility, to get that platform that provides the IT side understanding of what's going on the facility side and vice versa. Frequently, this is where you get some major insights and aha moments, because this is data which, although it might have been existent and known by 1 or 2 people in the facilities team and or one or 2 people on the IT side, it wasn't known mutually to each other. Hence, any optimizations and any decisions were made optimizing locally and not optimizing across the two. So the integration of the two is really fundamental. And it doesn't mean that you need to implement both simultaneously. One logical lower risk approach is implement a monitoring tool followed by an IT asset management tool or vice versa. You'll get immediate benefits and ROI from one of those modules on its own. In fact, you should probably insist that that happens. But you'll unlock incremental value that's greater than the superset of the two operating independently. So a typical example is really how the two work together to increase the operational effectiveness of the IT and the facilities teams. Typical situation of, I have a bunch of servers to deploy. IT has a good idea where they want those servers to be in terms of where they fit next to particular storage equipment, next to particular switches, next to other application servers, and frequently there's a tug of war between them and the facilities side, who has a much different idea of how workload should be distributed within rooms, across data centers, to mitigate their risk factors. And you get this ping pong going back and forth between the IT and the facility side. Having an integrated understanding of what you have, what's coming down the pike, and how it's operating, so you really understand how much extra capacity there is, and be able to fit things in and be assured that you're not going to run out of power, that you're not going to be undercooling. That time frame can be reduced substantially. One big bank was able to reduce this from a 2-week cycle to a 2-hour cycle. So that's 2 orders of magnitude. And it means the assets are up and running and generating revenue for the companies that much faster. And also, they found that the misplacements were reduced by 90%. Another example is from a software developer, where they trusted the combination of these tools to the extent that if they're talking about single servers of smaller size and smaller wattage, they actually trusted the infrastructure to the DSIM tools to the point where the IT people could come in, follow a set query process that says, the system tells me I have enough power, space, and cooling if I put it here where I want, and notify the facilities people. That cut out a dramatic amount of time and labor from the process. So as they were able to more than double the size of the data center, they were able to do that without adding staff. So the labor savings versus what they would have had amounted to about $380,000 per year. So this is a case of a synergy between the asset management and the monitoring tools that results not in power savings, but in labor savings, which isn't necessarily what people think of first when they think of DSIM. So that's a good do. A don't is don't be an island. Don't have independent, stranded monitoring solutions, such as might come with individual pieces of equipment. You'll have monitoring tools associated with power strips, associated with cooling units, associated with the servers, associated with the generators and the UPSs. You'll have a different BMS at each location. Each of those typically monitors only what it needs to monitor in order to control something. So you'll have an incomplete picture of the end-to-end operation of a data center if you rely on these piecemeal solutions. We don't advocate throwing out. In fact, we don't advocate touching those at all. We advocate bridging those and really connecting all these islands. And in the process of connecting, you'll find that there are a number of holes that aren't being monitored at all, where a DSIM monitoring tool can monitor those pieces directly. Very frequently, it's something like branch circuits that don't get monitored, or it's individual pieces of equipment that don't get monitored, or you may not be monitoring the environmentals, the temperature, the humidity, et cetera, that forms a key part of the understanding of what's going on in a data center. So when you start by being disconnected, each of the silos, each fiefdom within the data center is operating purely on the basis of the information that they collect that's under their purview, which means, again, they're operating only optimizing their own piece and not looking at the whole. The solution, of course, is to bridge these islands with and into a single pane of glass. What is that single pane of glass? It's taking each of those islands, which may speak different languages, may speak different measurement units, may define things in kilowatts versus watts, may have PUE calculated in different ways. A good DSIM monitoring tool takes each of those, normalizes that data, and presents that in a common format, translates the jargon from every protocol, every vendor, connects additional sensors, and gives you the end-to-end picture of what's physically going on in a data center from top to bottom. In order to do that, of course, one thing you need to do is be able to speak of each different BMS's language, speak each different EPMS's, electrical power monitoring systems language, speak of each different hardware manufacturer's language, speak each software tools and each industry standard software language, so speak the BACnet protocols, understand the Modbus protocols, speak SNMP, and use the appropriate protocol for the piece of equipment. The question that comes up often is which protocol is the best to use, and very often you're not in the luxury position of dictating the protocols because you typically have a hodgepodge, a heterogeneous environment where you have different pieces of equipment speaking different protocols, and it's a Tower of Babel. No problem if you have the appropriate DSIM monitoring tool. If it speaks all these languages and can normalize them and translate, you have that single pane of glass without really touching what's currently working locally. So this drives us to the view that you really have to look down at a very discrete micro level of data, which is fine and it's necessary eventually to do in order to get a complete end-to-end picture. You have to look at all ends of the data center. However, what often happens in implementation is you look at that lowest level, that most discrete level of data, and you get caught up in making sure you have 100% coverage of every single piece of data that you might possibly need. and you forget that there's an 80-20 rule. There's that Pareto point at which you have enough data to start making some insights, and rather than wait until the whole implementation is complete, you can start using the data as it comes in to start making some top-down decisions. So it's that failing to take the top-down view that often leads to a stranded DSIM implementation, because you're constantly waiting for that magic moment someday where you're going to achieve 100% coverage of everything. And we all know you'll never achieve that perfection, that nirvana state. So what we advocate is look top down. See, at what point you're able to see the big picture. If you have multiple locations around the world, if you have multiple locations, even if you have a single data center that has components and floors and cages and rows and racks, and you want to be able to look at the data down to the server level perhaps, but you can also zoom out and start looking at the forest rather than the trees and get substantial benefit before you've completed the rollout. In fact, in guiding the rollout, and all of this, of course, comes with a cost, there's a question of, is this worth the extra effort, the extra cost, the extra time, the extra processing power, the network bandwidth to monitor at the processor level? What am I going to do with that data? How is that going to be valuable? And is it worth that incremental cost to collect that data? So by looking top down, you get immediate benefits, and then you can layer in additional benefits from drilling down. If you start on the bottommost level, you may never get to the point where you can see those benefits. So that's one perspective. The other perspective is, within limits, do monitor everything that's possible to monitor, because sometimes you never know what data points on their own are going to be useful or useful in combination with others. So there is a TMI, too much information stage, but with DSIM, we believe what's more important is that you collect that data nonetheless if you have the right tools that use that in order to drive alarms and alerts, in order to drive decisions, and if you have the right tool that organizes the data, categorizes what's currently relevant, topical, and important, then collecting that additional layer of data provides you additional richness, which you can data mine. But again, it's start with the most important bits of data and then start working your way down the pyramid rather than from the bottom of the pyramid and going up. This is a corollary of the islands. So don't limit the data that, don't limit the user base of this data. The whole value of a DSIM monitoring tool is in exposing data from one department to another, from one function to another, from one location to another, and up and down the organizational chain. So it's allowing the IT staff to see what all the different other IT functions do and the facilities function do. It's giving this executive suite the ability to see what my power consumption, my PUE, my efficiency, and numerous other metrics are across all my data centers. If you're a colo or you're a data center that's rebilling departments for their applications and for their use of IT, it may be some data that you wish to expose to them. A tenant may want to see what the power consumption is, may want to see whether you're on generator or on UPS backup, may want to see if you're running out of capacity. That helps, that shared access to data helps both sides to support and maintain higher SLAs. It's also data that you expose to non-humans, i.e. to applications. If the application becomes aware and the measurement of the effectiveness of applications includes the ability to see what impact, what power consumption, etc. Many of these applications are ones that will control both the physical IT, the virtual IT, and the physical facilities infrastructure. So being that conduit, that aggregator of real-time data, power and temperature data, provides the foundation from which each of these control applications can function. Which brings up an important point and distinction that monitoring and control are completely different functions. Control requires monitoring data, but a monitoring tool itself, particularly in a mission-critical, sensitive environment, should not have control capabilities built into it. The value of a monitoring tool is precisely that dissemination of data to a broad population. Control, whether it's controlling the chillers or the generators or the servers, inherently you want a very limited population of experts to be able to control or have access to the control tools. And in a sensitive environment, the normal protections of passwords and authentication are not enough. The best way to ensure that nothing happens accidentally, either through accident or through malicious intentions, hacking, sabotage, etc., is simply not to disable the control capability, but to have no control capability of a monitoring tool, which after all is likely to live and run on the backbone network infrastructure in your data center. Control systems typically would not, for precisely those reasons. So because they operate in different environments and different milieus, while a monitoring tool could and should send data to a control application, they should not be one application and certainly not run in the same environment. So that's a do. The next don't. While we can wax eloquently about monitoring, monitoring alone is not enough. You have to do something with that data, turn that data into information, into insight, into actions. And whether that's through various reporting tools and dashboards, agents, feeding other applications, monitoring is a building block. It's a step towards something. Collecting the data itself often immediately pays for it, gives you an immediate payback. However, you'll uncover and unleash additional return on investment by now connecting the monitoring to other applications. So in this case study, it's a financial information reporting company that was able to translate the monitoring data, understanding what particular loading and power consumption was going on in their server environment, and use that to drive a server consolidation project. Further to server consolidation, consolidating workloads and consolidating on the UPS and the PDU side to make sure that the big power equipment is operating within their most efficient loading bands, and was able to pay back the monitoring investment in 2.5 months. Monitoring provides real-time data as well as historical data. There are some monitoring solutions that just give you the current data, like a thermostat does. There's much additional value in having the historical data because you want to make decisions not just based on spot, but based on historical averages, and very importantly, from a capacity planning perspective, peaks and lows and highs, whether you're talking about temperatures or power loading or cooling capacity utilized. It's really how much headroom you have from the peak, not from what you have today. And that brings up the example of a COLA facility that we used the data collected in order to raise the temperature of their data center effectively by about 4 degrees with higher confidence, since they have temperature sensors now at the at a more than just an ASHRAE density, and they're confident that although they're operating at a higher temperature, that added layer of information and the proactive alerting gives them an edge with which to operate. Don't limit yourself in terms of scalability. Buy a solution that can handle the eventual volume. Even if you're starting small, make sure you can grow big. Do both the push and the pull. So there are some monitors, some devices that push information to you and push alarms. Others need to be pulled. A good monitoring tool can do both and integrate those. Not necessarily at the BMS level or at the island level, but certainly at the single pane of glass level, it stands to reason that you would have one global solution that's the aggregator, that's the monitor of monitors. Alarms, very important to note that you shouldn't just alarm on something having happened already. You should alarm on predictive analytics, something that's going wrong, something that's changing too rapidly, spikes in power and temperature that, if continued, will eventually reach a critical stage. But also important to have alarms on potential issues. So what are all the what-if scenarios if I lose my A side and go to the B side, and all the workload, all the power load goes from the A to the B? Is that going to take down the B side? I'd rather know that now than know if and when that situation actually happens, because then I can proactively address that. And here's an example of monitoring temperature gradients. So as the temperature changes, if it changes too quickly, even though it's currently within limits, I can still make some changes before it becomes critical. The last do really is, with all of this, follow the advice of Lord Kelvin and monitor, measure the impact of your monitoring installation, have a target or ROI, see how you're doing on power, on space, on optimization, on capital expenditures, because you won't know whether or not you've been successful, and if this is a phased rollout, how to modify your rollout plan in the future. So with the summary of the do's and the don'ts here, and I won't read those again, I think you will all have a copy of this presentation emailed to you, and I would like to open it up to questions.
Okay, great, great presentation, Seb. There's so much information. It's almost, it's like, can our audience actually formulate some questions to ask as well? So they're sharp individuals, and we've got some questions from the audience. So one question is, do you see any differentiation or any maybe recommendations for a smaller organization? You talked about the complexity to maybe start smaller, but could you maybe refine that answer a little bit to say, hey, what kind of ROI could a SMB, medium-sized business look for or anticipate or build monitoring-wise to get ROI versus, say, a larger company which might do something a little more sophisticated even at the outset?
Right. So some of the ROI categories, such as safely raising the temperature or understanding what's going on in the power chain so that you can squeeze out additional capacity, sort of overbook like an airline does with seats, the overbook the power that you're putting into a rack. If you add up the even the derated power capacity of servers, you'll probably find that there's a lot of power capacity that's underutilized. Those are quick wins and bangs for the buck. What you probably won't see are these operational efficiencies, because if you have a small team of 2 or 3 people, the benefit that a DSIM provides in that large bureaucratic environment where facilities and IT don't talk to each other, that doesn't necessarily exist in a small environment, because that may in fact be the same individual.
Right.
But there are enough quick wins, and the challenge for a small company is not to try to bite off more than they can chew. Same message for a large company, although they tend to have more resources financially and more tolerance for failure sometimes. But in a small company, you should start, I think, again, incrementally, look for some quick wins, and getting the monitoring down right and just getting everything connected into one solution should net you a couple quick wins with which you can then continue an expansion.
Okay. Hey, I just got a request. If you could flip back to the slide before, I think that would help the audience continue to ask questions, because they're definitely rolling in. Yep, yeah, there you go.
Okay.
Yeah, perfect. So it's such a strong list. So another question is about data collection. This is sort of a big data oriented question, and maybe the solutions I might postulate, maybe they manage this big data, but kind of could you describe a little bit how you manage this data, how the solutions kind of act on it, how they analyze it, and so forth. Kind of a, with monitoring, you're kind of taking polls, every minute practically. So
sometimes even much more frequently than that. So
yeah.
There are, of course, some things that happen at the time of polling that you want to push down to the node that's actually doing the data collection, that's comparing, is this data out of range? I better raise a yellow alert or a red alert, and there's a whole procedure and protocol of sending emails or text messages or logging trouble tickets and so on. So that's kind of one extreme. The other is having collected all this data, either on a continuous basis, aggregating it globally, or aggregating it by application, by rack, by room, by tenant, alerting on bigger chunks of the data, not just one discrete element. That's, again, real-time analysis. And then you have historical analysis, where most monitoring tools will have some number of reports that look at historical trends, look at capacity, but then also need to be able to export this data so it can be commingled with other data. So, for example, we collect a lot of information about power down to the server level and tying that into the applications that are running on the servers and feeding that into other solutions, so you can then get a complete sort of total life cycle cost. So a CFO or a CIO can say, this is what my total SAP implementation has cost, not just the hardware and the software, but also the operating costs. And so there's greater value where you can commingle that. So we're, in addition to providing some a data mart, as it were, we're also populating the data and storing it into various data warehouses where business intelligence tools and all the big data with quotes around it analytics can then take over. So the question's always one of how much of that's built into the tool versus to what extent do you rely on the outside. And for us, the line of demarcation is the point at which you need to integrate external data that's not part of what you're collecting. That's when you really need to hand over to that big data analytics platform.
Yeah, yeah. Well, that's a perfect segue, if you will, to the next question around implementation. A lot of times, I mean, you know, Nlyte is a software vendor. A lot of vendors, you know, they get concerned if someone tries to implement a solution on their own, and some certainly are doable. Do you have any advice or any tips about, hey, you should look at the company's own service, professional services capabilities, or are general system integrators good, or only use a certified system integrator? What have you kind of seen? And does it vary? I imagine it might vary a little bit by region, but do you have any general advice there about implementation?
Well, so like you mentioned, our customers run the gamut from very sophisticated IT organizations that at least feel competent to do this. In some cases, it's what's my core competency, or in many cases, it's I can do it, but I'd rather not because I'd rather put my resources elsewhere. It becomes a resource allocation issues. Very often we get customers that will have the vendor or a third-party SI do these implementations with the idea that they can take over, because there's always a concern that locking yourself in with any vendor. So I think while not that many do decide to actually bring that implementation in-house, having that as a capability mitigates a substantial risk element for them. So I think the suggestion is have a vendor who will offer you that capability even if you don't expect to take that, to bring it in-house or to send it to somebody else in the case of non-performance.
Yeah, yeah. It also helps you get up and running quicker, you know, to go to an expert who's done it repeatedly.
Right.
Okay, so I'm getting a couple questions that are more, I would say, clarification questions. So one is around capacity planning or capacity management. So could you just a little bit reiterate how monitoring plays a key role in capacity planning? Because I know at least one of the case studies talked to it, but could you just kind of re-highlight it? Because
right. So without real-time and historical data, any capacity planning exercise or system is going to use nameplate or some derated nameplate data to figure out what's currently being allocated, what's left to be allocated, and then that forms the basis of here's how much capacity you have and here's what you need to do in the future based on knowing what the future plans are in terms of additional stuff. But having the actual data gives you the ability to pack more in. I call it's like playing Tetris, where you want to squeeze out every last bit of space, power, and cooling. And it's analogous to that airline analogy of overbooking, because you know historically you won't use every single watt at the same time of every server in every rack, etc. So if you have that historical data recorded, you can understand where your peaks are. You can also see what your consumption's been over time. Presumably, if you're a typical data center, it's not a static environment. It's entropy, and entropy in a data center means more and more stuff over time gets put into a data center. So your power draw is probably going to increase over time. Same thing for space, and same thing for cooling capacity available. So if I know what my historical trend has been, I can project the point at which I will be running out of either power or space or cooling, hopefully in sufficient time to be able to do something about it, either provision new or become more efficient at one of those dimensions. Very often, just understanding what the boundary condition is invaluable. And we have a number of customers that thought that they were entirely out of power, and they may be a 2-megawatt data center and say, I have 10% available, but you understand from real-time monitoring that they've never achieved even a third of that because there's so much redundancy and over-provisioning, that here's where a real-time view becomes invaluable in addition to just summing up what they physically have installed.
Yeah. Okay. Well, I've time for maybe one last question for a minute or two to keep it just on time here at the hour. And it's maybe a specific instance, but I also liken a little bit to kind of how you get started. And so one person on the line has 3 disparate data centers that they're looking to retroactively implement DSIM for monitoring. Is there any advice? Should they limit the monitoring to essential components only? Again, it's kind of like a question is where to start, where's the bang for the buck? You've definitely mentioned this a little bit, but maybe just a quick reiteration before we wrap up.
Right. So it would depend on, I think, the pervasiveness of monitoring at each of those. If each of those is pretty well, everything's pretty well monitored and already semi-aggregated, then the idea of installing that DSIM at that higher level where you're now polling those 3 locations and maybe just the high-level data, that forest, not the trees initially. So it's not a lot of data points that are being collected. The immediate bang for the buck will be that consolidated view. If, however, each location really doesn't have a single consistent view of that location, what you may want to do is go in and provide that end-to-end view and essentially monitor the power going into the data center through the UPSs, the PDUs, the transfer switches, the branch circuits, the power strips down to the servers, and at least in one room, so you can see what the benefit is of having that consolidated view, perhaps layering in, if there are no temperature sensors, installing some of that kit. And now that you can see what you get out of one room, and hopefully, again, have some immediate return from the visibility, now expand that to the rest of the data center and then go repeat the process in the other 2 data centers. So I'd say the answer depends on how much integration you already have in each data center. In short, if there's a lot, provide that high-level blanket layer that consolidates the 3. If it's not that pervasive, then try to get the benefit from integrating within that one data center.
Makes sense. Okay. Well, again, thanks everyone for all the questions. They were great. For those that we didn't get to, I'll route them over to Sev, and he'll respond to you. He's been generous enough to provide his email. So Sev, if you do me to go ahead and index to our last slide, take our final pitch. If you have other topics that you're interested in, DSIM Academy is really meant to have experts in DSIM present out, and we want to present on topics that you want to hear. So feel free to sign up at dsimacademy.com. You can register and hear replays. Again, everyone that's registered will be sending out the replay materials, audio, and the slides. So with that, again, I want to thank everyone on the phone, and especially to our presenter today, Sev. Great job, and thank you.
Thank you very much.